So if you've been watching this channel for some time, you may have already figured out I am not the biggest advocate for direct drive extruders. And I really don't have anything against them per se, but I honestly think that this whole argument that they're a lot better than Bowden and that's what you really want to direct drive, I think that's really missing the point of why the Bowden system was invented to begin with. But if I was going to consider going with a direct drive extruder, what would I be looking for? Well, first of all, you'd obviously want a light direct drive extruder because that's really why the Bowden was invented, was because you don't want to be carrying around the mass of the direct drive, which usually includes one of these large NEMA 17 motors. The other thing I would really want is a geared extruder, because a geared extruder is going to give you that torque, that extra power that you need in your extruder that's going to be lost by trying to lose the weight of one of these larger NEMA 17s. So if I had all of that, I would probably consider a direct drive extruder, which of course brings me to the subject of this video today, which is what could be a real contender that would make me switch more of my machines to a NEMA 17, and that is the H2 extruder, there we go, from BIQU, or otherwise known as Big Tree Tech. Now, will this direct drive extruder be what I'm looking for? Is it light enough? Does it have enough power? And how hard is it going to be to install this on any of my printers, which of course I'm starting with my Ender 5 Plus right here. Well, that's what I'm going to be doing right here today on Kersey Fabrications. Let's get started. Editor Chris here from the future, and I'm going to be the one to get you started on this video. Well, the more I edited this one, the more I realized how much content I had, and I really wanted to leave most of it in because I thought a lot of it was relevant to this hot end. So first of all, some of you may want to watch this all the way through and really enjoy the level of detail that I give something like this. If you're not one of those people, I wanted to give you a couple of suggestions on how to watch this. Number one, if you are a person that knows exactly what you want to see here, go check out the description for the table of contents, where I list all of the different chapters in this video to help you find exactly what you're looking for. Now, if you're a person that maybe does want to watch it all, but maybe not real time, if you're new here to YouTube or if you've never really thought about using it, check down, I think it's over here, but in the bar of this video, you will find the ability to run this at a higher speed. And let me be honest, I watch a lot of my own content using that feature, playing at 1.5 or 2x to get through the longer form content. So if you're into that, go ahead and just run this at a faster speed and you'll get through the whole thing. So just a couple of things to try to avoid the too long, didn't watch kind of comments down below. But anyway, I do hope you enjoy this. I put a lot of time and energy into it, particularly in the editing, to make it as condensed as possible. But as you know, I do film a lot and I wanted to include a lot of it here. The other thing I want to mention is I did cut out the entire section on me installing this on this printer, but I do have all of that content. I decided to cut it out because it does self-contain pretty well, and I do plan on publishing that in my next video. So if you want to see all of the details about how I got it installed on my Ender 5 Plus, that's going to be the next video following this one up. So I hope you'll join me for that one. And finally, I wanted to thank the sponsor of today's video, PCBWay, for making videos like this possible. PCBWay is my go-to source for printed circuit boards when I am designing my own projects. In fact, I found PCBWay before they found me, and they were the very first place that I ordered PCBs from. They have a killer deal for $5. You can get 10 boards, all of the details on the website. They can also handle your PCB assembly, particularly with those surface mount parts, which may be difficult for you to do yourself. They also cover flexible PCBs, and if you're a nonprofit, educational, or engineering group, they offer sponsorships for your projects. So check out, again, the website for full details on that. They have fast shipping, fast turnarounds, All you have to do is upload all of your relevant files and you will be ready to go. They have an excellent website where they will walk you all the way through the process from upload to shipping, keeping you abreast of everything that's going on from start to finish. So again, thank you to PCBWay for sponsoring today's video. Now let's get on to the content. Be sure to stay tuned to the very end of this video, past my conclusion, past my final thoughts, for one final update on what I think about this hot end after using it a little bit more than just my review process. Oh, and one more thing, please keep in mind that this video primarily focuses on the all metal heat break version of this extruder slash hot end, because that's what I prefer to run on my printers, because that allows me to print any filament without damaging that PTFE insert that is in most heat breaks. So if you see this video comparing it to some other video that reviews this hot end, my guess is they probably did not run the all metal version. So keep that in mind as we move forward, particularly into the test prints and any criticisms I have of this hot end. So here we are with the H2 extruder box. Let's crack into this and see what it comes with. It says it comes with the accessories and the tools. So if you're wondering, I got mine from two different locations. One of my H2 extruders, this one right here, came from BIQU directly. They sent me a review sample. And I also have another one that I received when I did one of their Kickstarters and purchased it as a separate add-on. So I've got both of these. I can take a look at them, but I don't believe there's any difference between the two. So very nice packaging. Hopefully you can see this. It is pretty dark. It comes with the data sheet and instructions. And then the packaging is very nice. They've got like this velvet coating on here. Maybe difficult to pick up on camera, but there we go. It's a nice velvet coating. You pull off this little insert here, and then we have our extruder. We can go ahead and pull that out. As you can see, it comes with the heat block. It comes with a 0.4 millimeter nozzle. It does have a beautiful sock on here to keep everything nice and neat and keep the heat in. Now it's got the cooling area here. This acts as the cooling heat sink for the hot end, and this whole piece is one big piece of machined aluminum. As you can see, they actually have this design here which is supposed to take the air, and instead of blowing that air onto the hot end area, it will whisk it away to the front and top of the machine, which is definitely the way this should be designed. It's very similar to the way that Humera has designed theirs. I don't have a Humera here to compare it directly to, but I'm sure you can find pictures to compare that online. Obviously we have the relief knob here, which will make it where you can push filament through it. Now this is an interesting part. This is a very small NEMA motor. I believe this is a NEMA 13, I think. And then they geared it down so that it would be able to spin quick but apply a lot of torque to our filament. They kind of assembled this one weird, as you can see. I don't know why they did this, but the power cable is coming to the bottom, which it obviously should be going to the top. Maybe they just did that for packaging, but we'll be able to easily turn that around when we disassemble this, and we'll definitely be doing that. They have a nice manual feed right here, which I really like where they put this. I think this is a really nice feature. It feels like it has a lot of torque. Next thing we need to do is disassemble this. I think we're going to do that right here with these two screws. Let me grab a driver. All right, so let's pull this apart. One screw here, one screw here, and those should then pull out. And I think this should just pull apart at this point, and it does. Not exactly sure how everything goes together, so I'm being very careful here. And as you can see, we have all metal gears in here. Great gearing system. I want to make sure everything's tight in here while we're in here, and then we won't have to come back in here later. And I do recommend, if you get an extruder like this and you've seen a video, you know how it comes apart, how to reassemble it, this is a really good time to actually take advantage of the fact that it's not attached to a printer, and actually pull it apart, make sure everything looks right, before you actually go to put it in your printer and then find out there's something wrong and have to take it back apart later. There is a bearing on this end, which is really nice, and there's a milled out part in there. There we go, to put that in. And then there is this grub screw on here holding everything together. Again, this is all metal. While I'm in here, I can go ahead and I'm just reaching around to grab a screwdriver. I want to make sure, that's too small. I just want to make sure that this is good and tight while I'm in here, and it's not moving. It's good and tight in there, so that's good. There's one of those. The only thing else on this side, you can see there's another gear right there. I'm trying to get a good shot there. As you can see, there's a light on there. Now, this doesn't appear to actually come out, at least not easily, and I really don't want to lose springs or other parts, so I'm going to leave that in there. That seems to actually be probably pressure fit in there, so that's not coming out easily. But anyway, that gear in there looks really nice, so don't need to disturb it. And there's a spring in there that's doing your tensioning on this knob right there. So the other thing I'm interested in here, let me go ahead and take off this sock. As you can see, there are two, hopefully you can see, there are two grub screws in here that are actually holding this on so that I can put in one of my all metal heat brakes. Now, I keep going back and forth on this. Do I want to install it as is? Do I want to go ahead and put in the all metal heat brake? I think I've about decided that since I don't want to have to tune this more than once, since I don't want to actually have to, do all of the height adjustment and everything later, I'm going to go ahead and swap this out now. So I should be able to twist this off, at least I hope so. First of all, I've got a screwdriver that has the correct size driver on the end of it, and that should take out our nozzle, which is really in here tight. There we go. That will come out. Again, that is a 0.4 millimeter brass nozzle. Pull that off. This then comes off because those were actually pressure fit against each other. Now, I do notice this is pretty symmetrical on here, so I don't really have to worry about which way it goes back together. I'll loosen that one. And then it's going to hold on to it and not let it go. And then I'm going to do the next one. Okay. This should then pull out of here. Notice that since my grub screws are on the back, that my flat part needs to be towards the back as well. Now, okay, so there we go. There is the PTFE tube. In this one, it is a blue PTFE tube, but I don't want that, even though it is really nice. I will say, looking at this, I'm impressed. It's a well-centered one. It looks like a fairly small diameter one, so I am impressed with the PTFE tube that they used, but that's not what I'm going for. So, let me grab one of these all-metal ones. I believe these are titanium. They might be stainless steel. I'll have to double check on that. And of course, I'll put it up here on the screen. All right, we're going to put this back together the same way it came. Push that tight up against it. I'm going to hold that in like that. And then tighten it all back together. You want good contact here so that it whisks away the heat. If it turns out to not have good enough contact, I could go ahead and put some heat sink compound or something in here, but I'm going to just try it without it to start off with. I think it'll do fine. All right, I'm going to screw this on here. I believe it goes this way. Okay, leave some room for my nozzle. That's a little too, not far enough. Now it's up to you. I've got some different opinions on this. There's part of me that wants to make the actual nozzle go flush with the base of this, and then there's part of me that says it doesn't really matter. I'm sure everyone has their opinion. You can definitely leave those in the comments below, depending on what you think about the proper placement of that nozzle is. I'm going to basically leave it the way that they've had it. Go a little bit closer, go almost all the way up those threads. And this is how they had it when the other one was installed. So let's go with that for now. Hopefully that's the way to do it. We tighten this down. This tightens the whole assembly. We definitely may want to make sure that we retighten this when everything's heated, but that should be good and tight. I'll go ahead and put back on my sock. All right, so that's it for that half. I can go ahead and reassemble this part into here. Let's take a look at the other half. So the other half of this is, as I said, this is our small motor. And we've got two more. Oh, be careful. This has our bearings on it right there. And there's another bearing on that end. That goes right into that milled space. And then this is the motor coming out here. That may be actually pressure fit onto that motor. We could technically find out by pulling it off of the motor here and here, which I think we wanted to do anyway so we could turn that motor over. Let's pull that off because the motor is slightly offset. Okay, there we go. And we're going to turn that over 180 degrees. And then that's the way it'll be reassembled. It does look like that's pressure fit on there. A little tiny piece of something on there, but other than that, it looks really good. I'm going to put that back together like this. I guess it'll be like this now. And we'll put back in our screws. And one more. Okay, there we go. Tighten that back down. Okay. Now this, of course, again, this all looks real good. All metal in here again, all metal gears. That goes there. I'm going to take and put our bearing back on there. These bearings spin really well. And then I'm going to take this and should go back together. Notice you can line up this pin here with this pin, or with the bearing in there, and that should all go back together. May take a little bit of fiddling to get everything to line up just right. Go with your knob here a little bit. If things don't go, there it goes. If it doesn't go back together, just pull it back apart, make sure everything's lined up. Try again. Oh, and I wanted to mention on the actual extruder itself, notice it is grabbing the filament from both sides. It has this knurling pattern in here. I guess that's a knurling pattern. If not, I'm sure you'll let me know. But it's got the pattern here. It also has the pattern on the other side, which you can't really see in here very well. But that will hold on to our filaments. There we go. Okay, I've got it. Everything inside should move again. I can test it by moving that. Moves pretty smoothly. And now I can just put back on my screws, which will tighten everything back down. All right, so that piece is now ready for assembly. Let's see what else comes in the box and what we have to work with when it comes to installation. So as I showed you, I threw back in the one that it came with, the heat break that it came with. Let's see what's on this side. Okay, so over here we have a thermistor. And as you can see, this one's a little bit different than our typical thermistor. This thermistor actually has a protective metal housing on it, which means we will not be able to use the thermistor that comes with the machine. We'll actually need to use this one in order to get everything attached correctly. We have a heating element, which technically I believe we could use the heating element that it came with. I think it's the same wattage. But since we're doing, I'm going to go ahead and use the one it comes with, and I'll show you how I hook this up. It comes with a correctly sized fan to cool the heat sink on the side here, as you can see. So this is hopefully a 24 volt fan, and it is a 24 volt fan, so we're all set in that department. Really long wire. I believe all of the wires here are going to be 1 meter long, which sadly will work on most printers, but will not work on the Ender 5 Plus. So you're going to get to see how we cut these down for the Ender 5 Plus. We have a fan grill to keep our fingers out of the fan. We of course have our usual rubber ducky because it is a Big Tree Tech BIQU product. We have a bunch of tools and extra screws that you may need for assembly. It's nice that they include that. And last but not least, they do include an extension cable for your motor that should work in most circumstances. Now, the only reason you may want to buy one separately as opposed to the one they ship with is that this one that you can purchase separately actually has a nice connector, just like the one that came on the previous one, so that you can just hook those together, not to have to do any cutting and soldering to, you know, extend those wires out. So that's why I grabbed my own. And that's it for what's in the box, which means it's time for installation. Let's head up to the top of the printer where we will begin. So I'm going to do a full PID tune on this hot end, and then I'm going to be ready for some test prints, and we're going to see how they turn out. Again, first ones are done with the default fan here. Second ones, I'm going to go ahead and do a replacement here and check out a bigger, better fan. And we'll see how they turn out. I'm going to just, of course, test prints I showed you before, which is the Deadpool and a Benchy. And then we're going to compare it to the other cooling solution. And then if I'm going to do any other test prints afterwards, it's going to be whichever one of those cooling solutions works better. So let's get to the test prints. Now for the first test print, I am noticing you can definitely hear this extruder run. I'm hearing the retractions pretty clearly on here. And obviously they're too far, as I said, because the retraction settings I have on here were meant for the stock hot end. But you can't hear it, it's cranking. All right, so the second print is done with that cooling solution. And what we've got here is a Deadpool print. Now let's take a look at this one and see what I think about the quality. And so far it looks absolutely gorgeous. Excellent consistency on some of these edges. Excellent consistency pretty much throughout. I don't really see any issues at all. I'm not seeing any ringing. I'm not really looking for anything that could be related to retraction issues because I haven't dialed this extruder in yet. This is just taking a look at the cooling. As far as the cooling goes, these are the parts that we're interested in. Now this, you can tell, it's not perfect. This looks pretty good here. It's got a pretty rough overhang in this area, but none of those are loose. They did at least melt to the neighboring pieces. This side's actually a little bit better. Still, as you can see, it's not perfect, but let's see, one more place, the chin looks actually fantastic. The bottom of all of the pouches look really good. So I will have to say this cooling solution worked way better than I expected it to. And just to back that up, here's the first print. This is the Benchy, and same thing here on the hull, the bow of the ship. Excuse me. It's just almost flawless. The only actual issues I see with this are where it created some seam marks on that side of the ship, and again, we may be able to clean those up a bit with retraction. Overhangs here look really, really good. No overhang problem in the front, no dipping at all, and that looks fantastic. The only real issue I see at all is there's a little bit of an issue right here, but it's quite minor. And as you can see, it actually did a really good job with the extrusion. This is extremely glossy for this silver filament. It looks just about the best I've ever seen it print. So I'm really happy with it. While this one looks obviously terrific, I do still want to try my other cooling solution, this piece right here, which I showed you earlier. This takes a 50-15 fan. It's going to go on right here. Now once I pull this off, then I am going to have to turn my heating block 90 degrees and move these wires facing forward, because obviously if they're coming out the side, then it's going to hit these right here, which won't work at all. So again, I'm going to go and remove this. Going to go and spin my heating block back, and then I will show you how I install this part. Alright, after a fair amount of work, I figured this out. As you can see, they're going to the back now. They're definitely not coming out the front. And what I had to do, ultimately, they won't go around the back. That's too dangerous. There are wheels in the way, and it requires a whole lot of slack to even think about doing that. So what I did, I just routed them through this little passage on this side over here, which I'll show you post-production here. Anyway, so it routes around this side, goes up underneath here. And I like that because it's pretty secure, because this is attached to this wire, so this is a big bundle here, and then this of course won't allow it to move at all. I did have to put slight bends on both of these wires down here underneath, but overall I think it looks pretty good. So let's get back to installing the new cooler. Again, this one goes here. I did realize after I talked to you earlier about this cooler that you're not going to be able to get to this either in here. This is the wheel that you could advance. You're not going to be able to get to it here either, because it's going to, of course, be covered up by the fan, which is not helpful. So there we go. That tightens on there really good. I really like the way that fits on there. And now we take, I like these Winson fans. Links in the description, but I really like those. And we're going to just put this down here. These are going to take M4 screws, I believe. And let me see, M4 screws. This one feels like it threads in, but this one goes all the way through. So I think I'm going to need probably an M420 there. M425 on this one with a nut on the back. And I'm also going to use a lock washer on there. There we go. And the lock washer, of course, is to prevent it from coming undone while we're printing, because there is a lot of vibration in this. And it helps us screw everything together too, because it holds that nut for us to a certain extent while we tighten that down. Let's see if that's going to thread into there like I think it does. Looks like it will. Yep. Oh yeah, that fits really good. I like that. Very, very secure. This one threading in and this one having the nut on it. I like that. And of course, this going back up to our pre-run wires before. This fan, of course, comes pre-wired. I didn't have to do anything. I'm just going to have to bundle up the wiring up into this area. Then we'll give it a quick test and see how it goes. Alright, so we're ready to test this out. And by the way, I did realize that these fan wires are wired backwards from the way Creality has them wired. So I did end up having to swap the pins on that connector. It wasn't a big deal. It took a very thin screwdriver, used the pin, popped them out, swapped them. Now this should spin properly. Let's cut it on. There's a little spin at the beginning to show us that it's working correctly. Alright, so now let's run this fan full speed, and I'll be able to test and see how well that's coming out of the bottom there. Alright, it's not too loud. I can hear it, of course. It's not too bad, but that produces quite a bit of air, and it seems to be relatively focused right below the nozzle. So I actually think the design on this is really well done. The air seems to be going right where we'd want it to. And of course the beauty is that it's coming from both sides there. So we're ready to rerun our BIQU and our Deadpool test print. We'll see if we notice any real difference between this one and the first one we ran. Okay, so the Deadpool with the new cooling solution is done. Let's take a look at him as well as the BIQU that goes along with him. So here's the BIQU, and looks much like the last one. No cooling issues whatsoever along the bow of this ship, and no cooling issues in the doorways, on the front here. The actual only cooling issue I really see, there's still a little touch here, but it's actually a little bit better than it was on the stock, which you can see right here. As you can see, this one is a little bit more damaged than this one is. This one's passable, this one is pretty messed up. So for that standpoint, it looks pretty good. Looking at the hulls, again, the bows of the ship look pretty much identical. And the only thing I really see on this model at all is there's a little bit of stringing here inside that I'm not exactly sure why I'm getting that. But again, this isn't tuned for this cooling solution or even for the new extruder, so we're not really looking at that. We're mainly looking at cooling to see which one we're actually going to go with. So there we go. Looking at the Deadpool, see how this one looks. Again, chin looks fantastic, much like it did on the other one. The underhangs here, the overhangs here, excuse me, look a little bit better than the ones we got on the previous one. It's not a dramatic difference at all. It's just a little bit better. And looking at the other side, again, this is off of the new one. Again, looks a little bit better. In fact, this one is almost perfect, except right here towards the back. Other than that, you actually wouldn't know this was an overhang. It's so well done. Which you still see a little bit of the cooling problems on this one. I think you can see the difference there, and again, the differences there. Looking at the underhangs, overhangs on these, again, no real difference. And on the katanas, nothing really there. What's my summary on the original cooling fan solution versus the new cooling fan solution? Well, this is very much passable. In fact, I have to say it's actually way better than I expected it to be. I think that the stock cooling fan with the fan that 3D Print General had designed for that actually works extremely well. So if you go with this one, it's got my blessing because it actually did a lot better than I expected. Now, if you want a little bit better cooling, if you want to be able to kind of go extreme on your overhangs, then this cooling solution is still just a little bit better. Given that it's only one fan, it really doesn't add much noise to your overall print. And if you're already doing all this wiring up here anyway, I don't feel like it's very much more to just go ahead and adding that one connection. Plus, it, of course, gives you a lot of modularity for this in case your fan dies at any point. You're going to have to do it anyway. So, which one am I going with? I think it's pretty obvious. I like extreme cooling. I like to really be able to control that cooling on that model. So, I'm definitely going to go with the new cooling solution. Kind of also like the profile here. I think it looks really good. And since I was able to route the wires and everything around the back the way I did, I actually really like that. I think it's a very secure solution for that. So overall, I'm happy with this one. I'm going to leave this one on here. And I know I'd originally talked about moving my BL Touch to the front, but since the BL Touch fits so well on this side, I think I'm just going to leave it there. I've already got my offsets in place, and if I were to put this here, I could potentially run into the front of the printer anyway with that BL Touch, so it's really not worth switching since everything mounts really well right there. So this is going to be the cooling solution that I'm going to go with for the test prints for this new extruder. Now it's time to actually do all of my testing. Let's figure out the temperature settings and the retraction settings for this, and then we'll be able to get going with probably just a really large test print, and we're going to see how it does on something that may take a day or two. So let's get busy. Alright, so while testing some extremely flexible filament here. This is flexibility from Treed. I seem to have run into a problem. As you can see, there's some filament coming out down here. I can see that there's some filament on the top of my block here. So something about this path did not seem to work out as tight as it should have been. So I'm going to now pull this off. I thought I'd get it on tape for posterity. Let's see what it looks like. But I wanted to see the path. Crap. Hold on. All right, no harm. I found the pieces. I'll put those down here. Let's see. As you can see, there's filament coming out down here. And there's filament all in this area. So the path definitely did not stay clean. Let's get this one out if I can. Yep, I heard where that went. 1 second. All right, so as we can see right here, that path was definitely not as, you know, not open as we thought it was. In fact, it looks like it just completely missed the opening there when it got to here and went pretty much everywhere. As we can see right there, it's supposed to go down that little path right there. It did not, and we are left with a bit of a mess. I'm hoping this comes off fairly easily, but definitely not without troubles. So I'll heat this up, get it cleaned up, but as you can see, definitely not opening free. And it's a very, very tight opening, so I don't want to disparage this. Obviously, you can still go too flexible on this because that's exactly what happened here. And I'm left with kind of a mess. So let me clean this up, put it back together, try a different flexible filament. So one more time for posterity, I was going to try to print a little bit faster with flexible filament. And as you can see, I end up with another glob right here. Now, to be completely fair, this isn't actually from trying to print too fast. This is just from having the nozzle just a little bit too close to the bed and it immediately backing up and starting to click on me. And so what I'm just learning is that with this all metal hot end, the fact that all of this heats up, that there's no separation between the filament and the metal, that we melt too easily, particularly on these flexible filaments. So that's going to be my last attempt on this one. I don't plan on trying any more flexibles right now. You know, I may try it again if I ever need to print flexibles, but for now, this doesn't look like the best solution for that. So the test prints are all done. Let's take a look at what I have here on the table. First of all, the front two rows here. Now, the 3D benchies and the Deadpools by Eastman, these represent my comparison versus the Micro Swiss all metal hot end that I've been running for some time now. Of course, that all metal hot end from Micro Swiss using the stock extruder or maybe an upgraded all metal extruder. And what I really wanted to do with these was just compare the quality of the prints, see is there any advantage of going to the H2. Do I notice any real print differences that would give the nudge to going with the direct drive H2 over the Micro Swiss? So the two middle prints here represent the cooling test that I was doing to see which cooler I wanted to go with. All three of these here on the left were done using the same exact G-code, while the one here on the right is going to represent the custom G-code with the right retraction settings and everything. So what I want to compare for this test are my beginning one. So this is the Micro Swiss with the cooling I had on there, up against the new G-code on the H2. Starting with the benchies themselves, again, this one being the Micro Swiss and this one being the H2. Looking at these two side by side, the first thing I noticed right off the bat is that the H2 has a much shinier, glossier finish than the Micro Swiss. That must have to do with the temperature I was printing at, because there's not much else that really controls the glossiness or the sheen of the filament. Moving into the cabin of the ship, I noticed that my H2 is a little bit stringier than my Micro Swiss, but that could just be I need more time to tweak those settings just right. I'm not actually going to judge stringiness at this point. Looking at the overall quality, I still have a little bit of an issue right around the top of these windows on my Micro Swiss print. That may have been just something one-off on this. But I will say that the H2, the overhangs in general are a little bit cleaner on the top of each of those windows. I'm going to give the slightest of leads to the H2 on this one. I do like the glossier finish, and I do like the way that the top of those windows look on that one better. Everything else being just about equal. Moving to the Deadpool print, which is what I'm using basically because there's a lot of fine details here, as well as some flat surfaces to do comparisons of quality. Now, comparing these side by side, again, notice that slight sheen difference. It's not quite as noticeable on this print. Again, a little bit more stringing on here. May need to dial it in a bit better. There are some cooling differences between the two. Again, that's not a direct knock to either extruder because, again, you can change cooling solutions on both of them. I think the Micro Swiss must be a little bit better tuned in than the H2 is, even though I do go through the exact same tuning process for both of these, because I just have less print artifacts on the Micro Swiss than I do on the H2. You'll notice this particularly on the katanas, on the edges of the katanas. For whatever reason, either the slicer or the hot end itself, it actually is leaving some pretty nasty seams. I don't know why I'm seeing those, given that all the other settings in the slicer are just about the same. But other than that, I would say that they are pretty equivalent. So slicer, hot end, I kind of leave it up to you to decide. It would take a lot more testing really to be sure, but prints alone, I like the Micro Swiss better, so a little one for one. Judging them purely on these two models alone, I say it's kind of a toss-up. I think that the print quality is going to be comparable when printing with PLA between the two extruders and hot end solutions. So not a real clear winner on that one. Now, one of the things you saw 2 seconds ago in this video, hopefully, was me trying to print with TPU with the all metal heat break. And I have one print to show for it. So as I was showing there, the all metal heat break is just causing a huge problem for TPU. It heats up too much. If you miss extrude because there's so much power in that extruder, it just squishes it down in there, it melts it, and so unless your print just goes perfectly, it doesn't keep going. So I got one perfect print off. This is a tire for the Open RC Racer that I found on Thingiverse. Thought it was perfect to print in TPU. This one actually turned out really well. So again, if you can get it to print, if you have the perfect circumstances, it'll turn out really well. It'll turn out just like your PLA prints. Again, with TPU, you're going to have a bit more stringing. That's just the nature of the material. If it crosses over at all, you can get rid of a little bit of that using slicer settings such as coasting. But on this one, I'm really happy with the quality of this. This one turned out really well. So for the last 3 prints I've got here, these beautiful bright blue prints, I tried out BIQU's own premium PLA filament, and this is their BIQU blue color. Printing temperature is 195 to 225, 30 to 60 bed temperature, printing speed 40 to 80. All the usual stuff that you would normally print with for PLA. But I have to say, just going straight into it, the quality of these prints are fantastic. I really love this filament. The filament works out great no matter what hot end or extruder you're going to go with. The quality of this filament is very, very good. So starting off, since I was doing new filament, I did full tuning on it. You can see that in another video. But this benchy, printed in their filament, completely tuned for this filament, turned out just about perfect. It's better than the other one I printed even. The seam is still in the same place. It still has the same high gloss finish, but the tops of those windows look fantastic. The surface finish overall is very, very nice. And I have to say, this BIQU filament has that hard PLA feeling. PLA sometimes comes in a sort of harder texture or a softer texture. This is a really nice, tough PLA. I really like how this bid sheet turned out. Next thing I did, I wanted to do something with some overhangs, and the print turned out fantastic. This is the Hypercube model by Laser Zord 10, link in the description as always. The tops of all of the extrusions here look super, super clean. You can go down each of these. There's very little to no variation in where that line should be made, and it looks really, really good. On the bottom, since these are pretty extreme angles, you do see a little bit of noise in those. It's not super clean, and I can definitely run my finger across it and feel that it's rough, but it printed the whole thing. The whole thing printed full size. I was really happy how this turned out. You'll notice, obviously, first thing you'll probably see on screen is that it's got a lot of stringing. So again, I'm still seeing some stringing that is either this not being quite dialed in correctly, or potentially it's that all metal heat break that is causing some stringing due to maybe some overheating of the filament or something like that. And finally, the centerpiece of all these test prints, this beautiful Rebel Alliance mug designed by Hex 3D. And this is just about a perfect print. I had to put the seam somewhere that it would not be seen hardly at all, so the seam is hidden on this side where the handle is, so you will see no visible seams anywhere else on this model, which makes just everything else turn out so, so nice. The seam, you'll notice a little bit down here at the bottom, then it's hidden in the way that he designed this handle, and then you'll see some more seaming behind there. But other than that, the model printed beautifully. Again, the Ender 5 Plus printed fantastic, and it provided a very good, clean extrusion. And I can say that, like, there's no visible signs of it not providing a good, constant pressure. I chose this one because this has a lot of smooth surfaces, and if there was any inconsistency with the extrusion, you would have noticed it here. You don't see any here. All of the details are really tight. I see no ringing at all on this. And again, the only real visual defects I see are the seams themselves, and I see stringing a little bit in the handle, and there's some inside the mug, but nothing that isn't very easy to clean up. Out of all the prints, this is the one I'm definitely the most happy with. It just really, really turned out fantastic. So with all that said and done, the installation complete, and all of my test prints laid out here on the table, what are my final thoughts on the BIQU H2 extruder with an all-metal heat break installed? Well, first of all, let me send my thanks to the 3D Print General for making the installation just that much easier by providing the adapter plate in this video. You'll find a link to his channel and to that adapter plate in the description, as always. Now, while we're talking about that part of the installation, I am going to go ahead and say you are going to need to print those parts in something other than PLA, something like PETG, or particularly ABS or ASA would be the best choices. So why is that? Well, due to the way that this is cooled, the entire unit becomes a giant heat sink, and you have to cool it off just from one end with the fan. What that means is, while the entire thing isn't going to necessarily be too hot to touch, the whole unit is going to heat up, and that's going to make softer plastics such as PLA soften. And as that happens over time, the entire mount is going to get a little bit looser, and I experienced that in this review where I had to go in and tighten it up a couple of times because it kept getting softer. So print those parts, both your cooling solution and your mounting plate, in something other than PLA. Otherwise, you could have some melting of those parts. So overall, what about the quality of the prints coming out of this extruder hot end combo? Well, as I just discussed, overall the print quality is very good. In fact, I can't say enough good things about this mug, which was really the centerpiece of all of my test prints. Comparing it to the Micro Swiss, which has been my go-to hot end for some time now, I would say that it's on par with the Micro Swiss. I didn't find that it produced particularly better prints than the Micro Swiss, but on the same note, it didn't produce particularly worse prints than the Micro Swiss. When comparing them as all metal extruders, I have to say there's not going to be a whole lot of benefit one way or the other in terms of the quality. The only thing you're going to get print time wise is that you're going to save a little bit of print time because you have shorter retractions, and that's going to save a little time given the number of retractions that are in a typical print. Now, as far as high temp filaments that are concerned, that's one thing I didn't tackle in this video just due to time constraints. I do have a little bit of reservations with this design as you approach that 300 degrees Celsius mark, because I worry that with just this one-sided cooling approach, you could really have some issues with the entire unit heating up too much and you not being able to whisk away enough of the heat. If this is something you'd like me to check out in the future, please leave a comment down below and I'll see what I can do. Now, when talking about flexible filaments, I just discussed one test print was all I was able to get out of here. Other than that, I had multiple clogs, multiple jams. Anytime anything didn't go perfectly right with that flexible filament, with that all metal heat break, it just clogged up. Again, I think there's too much heat buildup in there for these softer materials, and they just crunch down because it's such a powerful extruder. It keeps going even if it can't push through. So only one. I would say if you're going to want to print flexibles and high temperature filaments with this hot end, you may end up having to keep both heat breaks around, one for printing flexibles, one for printing the high temp materials, because I really don't think that they are going to be compatible in one extruder to do both tasks. One thing I haven't had a chance to mention so far is an issue that I had with this extruder, and that's a clicking. I kept running into this clicking with the extruder, particularly during retractions and extrusions. Now, I kept taking it apart and I could never really figure out what the cause was, and I'll tell you what I've done to try to mitigate it. First of all, I did open it one time and I found that the gear that was opposite the drive gear that, grips the filament on both sides, it was loose. That set screw that was in there had just come loose for some reason, and I had to re-tighten that down. This is something that I've heard from others in other reviews, that being a problem. Once I tightened it down though, I never had that issue again. The other thing I tried to do was to lubricate the entire thing with a little bit of this white lithium grease. Didn't really seem to do anything whatsoever. Still might be a good idea for something with moving parts like this to put a little lithium grease on the gears or on the bearings just to give it a little bit of extra lubrication, but it still didn't really seem to get rid of that clicking. Now, the clicking would come and go. Sometimes I would hear it more, sometimes I would hear it less. I've heard this from some other people that they have the same clicking, but I really couldn't figure out what the cause of it. Now, the last thing I will mention, along with all this maintenance I've been talking about, is what about the maintenance of this all-in-one integrated extruder? How much work is it to work on? And the answer is, it's a moderate amount of work if you need to pull it apart, because you do have to take off the whole front cooling solution, then you have to pull it apart, then when you're ready to put it all back together, you have to line up all of those gears inside, fit it back together, and there was always one pin or something that would keep the entire thing from pushing back together the way it should have. And again, I had to do this multiple times, so I got pretty good at it, but sometimes the reassembling was still kind of a pain. So if you're a person that's easily frustrated, this may push your buttons in the wrong way. But if you're mechanically inclined, I'm sure it's not going to be too big of a deal. Be sure to stay tuned to the very end of this video, past my conclusion, past my final thoughts, for one final update on what I think about this hot end after using it a little bit more than just my review process. So at the end of the day, what is my final recommendation on the BIQU H2 extruder? Well, it's kind of a mixed bag, to be honest. I didn't find this to be the all-in-one solution, the gold standard I was really looking for. I just ran into a few too many problems to say that it was easy, to say that it was hassle-free, or to say that it worked in every scenario. Now let me break this down into two things. First of all, if you were going with stock, if you put the PTFE tube back in there and we're not concerned with using an all metal extruder, go check out the 3D Print General's review. I think he showed that it's a fine extruder with that PTFE and hot end in it, and it does all the materials, it does the flexibles, it prints everything very well with very little hassle. I think what you're really going to run into, the other side of the coin, is when you want an all metal extruder for those higher temp filaments. And then you're going to run into the two problems that I've discussed. Number one, you're going to run into the flexible filament issue, which just doesn't want to extrude all the time, and you end up pulling it apart, and oh, that was a mess. And number two, you're going to run into the problem of how well is this really going to handle really heating the entire unit up and having to be cooled down at those higher temperatures. And again, I didn't get a chance to evaluate that in this one, but I have my concerns just seeing how warm it got for this PLA that's holding it all together in my testing. So my final recommendation is, it's a good extruder, but it's not a perfect extruder. I love it because it's lightweight. I love it because it's all integrated. I love the size of it and the power of that motor that is able to really push in a good steady stream of filament. But from an all metal perspective, it takes away your ability to print flexibles the way you're going to want to. And one thing to keep in mind, particularly on a printer this size with all these connections, it's kind of a pain to install. You saw how much crimping and soldering and everything I had to do to get this on there. Now with any all-in-one solution like this one that doesn't come with 2-meter long wires, you're going to run into that problem. But you know, for a solution that takes this much effort, it costs about $80 or $90, somewhere in that range, depending on where and when you buy it. It's not the perfect solution given cost, time, limitations. So it comes recommended, but with just a big asterisk of it's not the best that I was hoping it was going to be. Now obviously you're going to see different reviews online. I think the reviews overall have been very praiseworthy of this, but they're working under different circumstances than I was. I don't know of anyone that put it on an Ender 5 Plus. If so, leave a link in the description. Show me where they've reviewed it on this printer. Number two, I don't know of any other channel that's done it with the all metal heat break, and I'd love to see more of those if you've seen them before. But these are my opinions. I welcome yours as always. Check out other sources. Because that's what this is about. I'm one resource and there are a bunch of other ones on YouTube, so please do your research and see what you think. So with all that out of the way, let's finish up with a little bit of business. Number one, this extruder was provided by BIQU for review purposes. No other money exchanged hand. All they did was provide the product. And one other fun little note is I've actually bought a couple of these myself for other testing. So while they sent me one, I don't know if the one that I tested was actually from them. Kind of mixed it up to see what the sampling was going to look like. In fact, I actually unboxed a couple other ones just to make sure that what I saw in this kit was in line with what I saw in the other ones. They all look pretty much identical to me. Number two, as always, I want to thank my Patreon supporters who are running by the screen right here, right now. Those folks have been absolutely fantastic. They've been patient with me as I've been producing all these new videos, and they are the ones that help provide the motivation and encouragement to keep these videos coming. So if you are encouraged by these videos, if you want to help support this channel, you can join this lot over here by supporting me on Patreon directly. If that's not your thing, you want to support me directly with PayPal, that's also in the description. As always, none of that is required, of course. I'm just glad you're here. If while you're here, you would like to hit the like button, if you'd like to subscribe to my channel because you want more content like this, please do so. You know where those buttons are. And that about does it for this one. As always, there's a lot more content on the way. There's more how-to reviews just like this one, as well as just straight tutorial videos about 3D printing. I have some project videos that I'm bringing to the channel. So again, thanks for watching. I'm Chris. This has been Kersey Fabrications, and I will see you next time. Thanks for watching. All right. I've been using this hot end now for a couple of weeks beyond the review process. And I think this is always important to really get a feeling for what a product feels like, because running a bunch of test prints sometimes just really isn't the same thing as running real prints, trying to go through your normal everyday process. The idea of, let me go slice something, throw it in there, and just hope it works and see if everything goes to plan. And I'm glad I did that on this one, because if my previous conclusion wasn't lukewarm enough about this hot end, I wanted to be a little bit more clear here that I have had a lot of problems with this hot end. And I think some of it can be chalked up to the fact that I was trying to use that all metal heat break, but not all of it. I'm still having the issues with the all metal heat break where the thing is just getting too hot and melting some filament. As you can see here, that's not what this is supposed to look like. It has just been completely gunked up. I actually don't even know how all of this filament got on here, because I haven't oozed that much or had that many failures. You can see similar garbage in the end of this, and I'll try to, there we go. And I've just had a lot of problems. In fact, what's on here now is going back to the default configuration with the heat break with the PTFE tube in it, and I'm still having problems with it. Right now it is currently clogged, and I don't know why. In fact, it's my second clog since putting the PTFE version of the heat break on there, and I'm still having freaking problems, and I don't know why. I thought I figured out why it clogged the first time, and I fixed it. And then I come to the second time, and it's clogged again. And my biggest gripe at this point, sure, I can complain that it's failing on me and that I'm having to fix it. I don't mind fixing things, though. My biggest complaint is how much work it is to get this thing unclogged when it fails on you. It's a lot of work to take this thing apart. You have to pull the fan off, the cooler off, then your BL Touch is in the way, which could potentially be moved, but that's honestly where the BL Touch should be. You got to pull the fan off, then you can pull the thing apart, then you can start trying to get your filament out. Then if it's still clogged, you have to pull the bottom off to be able to get to your nozzle and everything. It's a lot of maintenance if something goes wrong. And that's stuff I don't have time for typically. I've spent 2 hours just today on this, and that's not counting the hours I spent yesterday on debugging it, where with the traditional micro Swiss setup I have on here, I've never spent that long with a clog. I've never spent that long with a persistent issue on it. I can clean it up and go, and you know. Anyway, I'm running long on this. I know I talk too much. But I just wanted to let you know, I am currently not happy with it, PTFE tube or not. And like I said, a lot of it has to do with the maintenance. It's a lot of work to work on. It's a lot of work to unclog. So, you know, as I always say, like I said it earlier in this video, there are plenty of people that, at least in their reviews, have talked about how much they love this hot end. And that's fantastic. But I have to tell you what I think. And right now, I'm going to spend some more time on it. But I've got to get this video out eventually. So I'm not recommending it right now. I'm having too many problems. Now, if you're a person that's using this and you want to comment down below about how you've had 0 problems and you really like it and, you know, it's just a terrific product, please do. I always encourage that, because your results are not my results, just like, you know, all the other people that may review this on YouTube. So I encourage you to do that. These are my results. I welcome yours as always, and I appreciate you watching, particularly all the way to this very end moment. So thanks again, and I will see you next time.